Hey guys, all right, we are still on 4.5, absolute, relative, and percent change. As we move from A to a nearby point called A plus gx, we can describe the change in f in three ways. Okay, so we have absolute change, so true and estimated. True means actual. So the actual change is going to be f of a plus dx take away f of a, as we know. And the estimated is d of f equals first derivative at a times the change at a, that's an a, times the change in x, which is dx. Next one is the relative change. Relative change is pretty much talking about comparing two quantities, okay? So for the true, we have the change in f divided by f of a. Over here, we have df divided by f of a. Then percentage, that's normal. We multiply everything by 100. So the change in f divided by f of a, and then times that to 100. Same thing over here, d of f over f of a times 100 if you want to know the percentage. Okay. All right, let's see what that is going to be used for. Example 7a. The radius of a circle is increased from 2 to a small increase of 2.02 meters. Part A, estimate the resulting change in the area. Estimate as a percentage of the circle's original area, which is good to know, right? If you move the radius 0.02 of a meter, I would like to know the actual number and what percentage is that, okay? So first, we might want to find the area. Area equals pi r squared, and I'm going to rewrite this as a of r because I want to find the derivative with respect to r, which, as you know, is really dA over dr. Okay, dr is the change in radius, dA is the change in area. If you know those values, you know those meaning, then it's easy for us to find the change in area, which is dA. All right, so derivative says power rule, drop down to 2 times pi times r, voila. Then I would like to solve for dA, which means I need to multiply both sides by dr. Would you agree? So dA equals 2 pi r dr. Okay. Since they gave you radius is 2, we know the change in radius was 0.02. We can totally plug that in. So dA equals 2 pi times 2 times 0.02. We will crunch out that number, which is 0.08 pi, which is about 0.2513. I would take this exact, or I would take the approximation. Okay. I can write a complete sentence in all of that in just in a little bit, but right now let's just work out the numbers. At the end, I'm going to write a complete sentence for both parts. B estimate as a percent of the circle's original area. So that means percentage means d of f over f of a, and then I'm gonna multiply by 100. Well, I don't have f, I don't have d of f, but I do have d of a, right? Because r is talking about area, d of area over, I don't have f of a, but I have the area, the change in the area, and area of r, okay? Remember, r was originally starting out as 2. Okay, so if we do that and we multiply by 100, we're good. The change in area we found, I'm going to use the exact value, which is over here, of 0.08 pi. A of r, which is really what am I doing? Why is it moving like that? A of 2, maybe I'm just hitting something wrong. Okay. A of 2, which is 0.08 pi divided by, if I plug in 2 square, because pi r square is my formula, whoops, times pi. Something is glitchy here with my computer. Times pi, that will help me reduce the pi. So I'm going to have 0.08, I'm sorry, over 4, and I do need to multiply by 100 to get a percentage. That comes out to be 2%. Okay, I get the number for both parts A and B, so let's just go ahead and write a complete sentence. Okay, ready? Part A said estimate the resulting change in area. So the estimated change in area is about, you can write it as 0.08 pi or 0.25113, and then we can add the percentage in, okay? The estimated change in area is 0.2513 meter square, and that's about, we said 2% of the original area, okay? Box it up. There you go. So as you can see, the change doesn't look like it's a big number, 0.2513. So as you can see, it's 2% of your total original area. Okay, let's do 7b. The radius of a circle is increased from 10 to 10.1 meters. Same thing, estimate the resulting change in area. If you went from 10 to an increase of 0.1 meter, what would be the area? And then tell me the percentage as well. Same thing, we're going to work out the same way. Area equals pi r squared, which I want to write it in terms of r, so I have a better understanding of what dA over dr means. So take the derivative, multiply both sides by dr, so dA equals 2 pi r dr. Your radius is 10, so I'm going to put in 10 for the radius, and dr is going to be 0.1, so dA equals 2 pi times 10 times 0.1. That will shoot out to be just 2 pi. And again, I'm going to write a complete sentence for both parts later, but let me just do the math first, okay? Part B, let's figure out what percentage that is in comparison to its original area. So we are going to do dF over dA based on your formula times 100. I don't have dF though, I do have A because that's the area over A of R. Okay. Well, dA, we already found it. It is right there. We can just plug it back in. So that's going to be 2 pi. A of area started at 10, so I need to find out what that is. So 2 pi all over pi r squared, so 10 squared times pi. Cancel out the pi, so that's 2 over 100. So I'm going to multiply by 100. So, oh, it's 2% again. Okay. So here we go. The area, as you can see, final complete sentence. The area as you can see, the dA changes to 2 pi. So area will have an increase, right? Increase of 2 pi meters square, and that's about 2% increase from the original circle's area. So that's about 2% increase comparing to the original's area. Comparing to the original area. Okay, original circle area. So there you go. And that's the end of example número 7.